Hello everyone, it's Meenal Jopi, Assistant Professor in Computer Department of AISSMS Institute of Information Technology, Pune. So today we will learn about logical propositions. So these are also called as logical connectives. So mainly logical connectives are and, or, negation or not, implication, and if and only if. So first we will see the proposition logical negation. So negation of a proposition A is false when A is true and it is true when A is false. So you can see that in the truth table, this is a truth table of logical negation. If the value of A is true, the negation is false. If the value of A is false, the negation is true. If I'll take the example as the number 2 is greater than 7. So negation of this statement is the number 2 is not greater than 7. So next proposition is and. This is also called as conjunction. So the AND operation of two propositions A and B is true if both the propositional variable A and B is true. So in the truth table, we can see that if both the variables A and B are true, then only the proposition value and A and B is true. Otherwise, it is false. Next operation is disjunction. It is also called as OR. So the OR operation of two propositions A and B is true if at least any of the propositional variable A or B is true. So in the truth table we can see that if any one value of A or B is true, then the disjunction value is true. So here one value is true, so disjunction value is true. Here also one value is true, so the OR operation is true. Here one value is true, the OR operation is true. Last both the values are false, so the proposition value of A or B is false. Next is implication. So implication is the proposition if A then B. So it is false if A is true and B is false. The rest of the cases are true. So in the truth table it is given that if A is true and B is false, then it is false. Otherwise, rest of the cases the value of A implication B are true. Next operation is biconditional connective. So it is if and only if connective. So biconditional connective is logical connective which is true when P and Q are same. Both are false or both are true. So if both the values are true, then it is true. If both the values are false, then it is true. Otherwise, it is false. So based on this, all logical operations, there is a tautology, so we can prove that tautology. So tautology is a formula which is always true for every value of its propositional variable. So for example, it is given that proof A implies B and A gives B is a tautology. So if we will find out the truth table of this statement, so the result of every propositional value is true, then we can say that this is a tautology. So for all the propositional values should be true here to prove it is a tautology. Then contradiction. So it is opposite of tautology. So a contradiction is a formula which is always false for every value of its propositional variable. So for this statement A or B and not A and not B, so here we have to prove that it is a contradiction. So we have to build a truth table here and the result of every proposition value should be false. Then only we can say that it is a contradiction. Then contingency. So contingency is a formula which has both the values true or false. It may be true or it may be false. Then the statement we can say it is a contingency. So here we can see that the result of the propositional output can be true or false. So it is a contingency. So this way we have seen here logical operation and or implication and by implication and the application of that logical operation, that is tautology, contingency, and contradiction. Thank you.